All right. You should take a few minutes, fill this out. So pause the video. There's a front and a back. This stuff should be reviewed. So the mean of p hat is equal to p, mean of x bar is equal to mu, standard deviation of p hat is the square root of p times 1 minus p over n. Here's your standard deviation of x bar, sigma over the square root of n. These above standard deviation formulas are only accurate if your 10% condition has been met. If you're talking about the sample proportion, to check the normal check, you do n times p or n times 1 minus p. If you're talking about the mean, the population is normal, or the central limit theorem applies. Again, if you're using the T procedures, the procedure can still give us fairly accurate results if a condition is not met. In this case, it would be the normal condition. As long as the graph shows no strong skew or outliers, you can use T. From Chapter 6, if we wanted to find the difference in two random variables, the mean would just be the subtraction of the means. Remember that the new standard deviation, you'd add the variances, so we'd still add them. We take the square root, so remember when combining random variables, we always add variances, never add or subtract standard deviations. Down here, if you wanted to find the probability of that being less than this z-score, you'd get this right here. If you were doing the T distribution, you could use T-CDF. You'd find that answer right there. This is so not true. I would never put that much sugar in my hot tea. All right, so this one right here. So what's happening here is I'm selecting 4 packets at random. So I am combining 4 packets here. So the mean of combining them is like doing the 2.17 plus the 2.17 plus the 2.17 plus the 2.17. So there's 4 of those. Then the standard deviation, I would be adding those variances 4 times. So I'm not taking one packet and multiplying it by 4. So I'm not transforming, I'm combining here. So, sorry, I'm just going to make this a full screen. So then once you get that, you get your mean and your standard deviation. So I want to find the probability that my tea is going to taste right, so it's between 8.5 and 9 grams. There's my probability, so that's my chance there. Here's your general form for your confidence interval. If you wrote standard error of the statistic, that's fine there, because remember, standard error is the same thing, except of having p, we would plug in p hat, or instead of sigma, we'd plug in s. And again, if you put the little x there, that's fine too. Same thing right here. You might have written standard error here, but for this particular one, it's pretty much always the standard deviation there. This chapter is very similar to 8 and 9. The only thing that's different is that we have 2 independent samples from different populations. We also have a section in here on comparing tests that you've learned to this point. Okay. I have to skip this activity here. I probably it's too hard to do remotely, so we're skipping it. All right. So this idea here, so I'm going to start here by talking about comparing 2 proportions. So many news organizations conduct polls asking adults in the United States if they approve of the job the president is doing. How did President Obama's approval rating change from 2009 to September 2010? According to a CNN poll of 1,024 randomly selected U.S. adults on September 1st and 2nd, 50% approved of Obama's job performance. A CNN poll of 1,010 randomly selected adults on August 28th to the 30th in 2009 showed that 53% approved of Obama's job performance. Use the results of these polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating among all U.S. adults. So again here, we've got 2 polls here. We've got one from 2010 and we've got one from 2009. So we have 2 samples coming from 2 different populations. So it's similar to what we've seen before because it's still asking us to calculate a confidence interval, but it's different because we're dealing with 2 samples and we're just used to kind of only having one. All right, so there's some things here, just some new notation here. So before we had just P, So you'll have P1 because you'll have two populations, and we'll have P2. And we had P hat 1, and we'll have P hat 2. So before we just had P hat, and we'll have N1 and N2. Okay. Again, today I'm just talking about the proportion. All right, today's problems. Again, general form for the confidence interval: statistic plus or minus the critical value times the standard deviation of the statistic. It will be the standard error today because since I'm doing the confidence interval, I have to plug in the sample proportion because I won't know this one here. In order to find the standard deviation of the statistic, we have to talk about the sampling distribution of P hat 1 minus P hat 2. So what's meant by the sampling distribution of the difference between two proportions? So basically, it's the same idea as before. Instead of having one P hat, so when we did the Reese's Pieces, we just had the proportion of orange. Instead of having one P hat, we now have two P hats. So I don't know, maybe I had the proportion of orange for the Reese's Pieces and I had the proportion of orange for the M&Ms. So this is not that scenario, but here's an example here. So here's the proportion for one of them. So the P hat 1's for one of them. Here's the P hat 2's for the other one. So the sampling distribution of P hat 1 minus P hat 2 is just basically taking the difference in all possible P hat 1's minus P hat 2. So it's just looking at that difference there. So when you think about that sampling distribution of P hat 1 minus P hat 2, we're thinking about all possible values of P hat 1 minus P hat 2. We're going to have conditions that need to be met. We're going to talk about the shape here, we're going to talk about the center, and we'll talk about the spread on the next page here. So to talk a little bit more here about the shape, center, and spread. So it goes back to a little bit of what we did in Chapter 6. So again, we talked about this earlier on the quick review. Those were our formulas there. The other thing you already know is that the mean of P hat is equal to P, the standard deviation of P hat is equal to the square root of P times 1 minus P over N. Those are from Chapter 7. So these are from Chapter 6, Chapter 7. So if I'm talking about P hat 1 minus P hat 2, the mean of that, I can just apply, so I'm taking the difference in P hat 1 minus P hat 2, I can just apply this formula here from Chapter 6. So essentially, what this is here is it's just saying here that the mean of P hat 1 minus P hat 2 is going to just be equal to the mean of P hat 1. So, sorry, this one right here is the mean of P hat 1 minus P hat 2. This is going to be equal to the mean of P hat 1 minus the mean of P hat 2, which essentially just means the mean of P hat 1. If the mean of P hat was P, the mean of P hat 1 is just P1. The mean of P hat 2, again, that's just going to be P2. So the mean here is going to be just your P1 minus your P2. So the mean of the sampling distribution would just be P1 minus P2. The standard deviation, I would have to add the variances. So now I'm going to add the variance of P hat 1 plus the variance of P hat 2. After I add those variances, I'll have to take the square root to have the standard deviation. This one right here, well, all I would have there, I'm going to erase something in a second here, but I'd have P1 minus times 1 minus P1 over N, and I'd square that. Well, if I'm squaring a square root, then that's pretty much gone. So I'm going to erase that. So remember, I'm squaring the standard deviation. So then I have P1 minus P1 over N1. Same thing's going to happen over here. I'm going to take something that's under a square root, but I'm going to square it. We're going to get this right here. So this is the standard deviation of the differences. So basically, I'm taking the variance of the P hat 1 plus the variance of the P hat 2 and taking the square root of it. Okay, so this is your standard deviation. If you wanted the standard error, which is what we're going to use for the confidence interval, we won't know, because in the confidence interval we don't know P1 and P2. So in the confidence interval we would plug in the P hat 1, and we plug in the P hat 2. And we'd call that the standard error because we're using the statistic, not the parameters. We're using the value from the sample, not the value from the population. Again, this is just trying to tell us, on average, how far away are these differences from the true difference. All right, for this particular example right here, we're just going to use this idea of the sampling distribution. So before we get into confidence interval. On a given day, the proportion of workers from company B who purchase a coffee from the company cafeteria is 0.62. So the proportion of B, so this is the true proportion, so it's 0.62. And the proportion of workers from company C who purchase a coffee is from the company cafeteria is 0.71. A random sample of 40 workers were selected from company C, and a random sample of 40 workers were also selected from company B and from company C. And it says the observed difference in proportions was 0. So we take a p hat from this 40 and we take a p hat from this other 40 here, and we take the difference in those two and we got 0 there. So first thing it says, let's describe the shape, center, and spread of the sampling distribution. So with center and spread, we talked about those formulas in the last page. The shape. So basically the idea here is if we can check the normal check for this one, and we can check the normal check for this one, if they both end up meeting that normal check, then together they would meet the normal check as well when I take the difference. So this is that normal check here. So I'm going to check the normal check for the first one. Now I'm checking the normal check for the second one. So all of these are at least 10. So what that tells me here is that if I had all those differences there, this should be approximately normal because all of these are at least 10. The center, so the mean of that p hat, notice here I used p, the true value, so the mean of the p hat B minus p hat C. This should all be a subscript. It looks like I kind of lost my subscript. Again, so the mean of that, so p hat B minus p hat C, I would just take the true p here minus the true p here, and I would get this value right here. And then to find the standard deviation, it's this one times 1 minus that one. So I'm actually finding the standard deviation here because in this particular problem, I'm not creating a confidence interval. I actually am saying I know this value is true about the population. All right, so what I've done now is I've turned this probability problem. I understand what the sampling distribution looks like. My goal here is to find the probability that p hat B minus p hat C is, it says, well here it says at least 0 apart. So I want to find that I'm greater than or equal to 0 there. I'm sorry, I should put this parenthesis here. So when I want to find that probability, again, I already know here that I can use the normal distribution. I'm going to use this value for the mean, and I'm going to use this value here for the standard deviation. if my mean is at negative 0.09, this is the standard deviation. It looks like this value is, so 0 would be like a little under 1 standard deviation above. Actually, it's a little bit more than 1 standard deviation above, right? Well, let's just figure it out, since I can't think right now. So that's, just 0 is still a little bit more above that then, right? Just getting all confused here. All right, you could convert that to a z-score. So that would tell me for sure how many standard deviations I was above, right? So I'm almost 1 standard deviation above. So then you could convert that to a z-score if you wanted, or you could just leave it like this. Because I want to find this probability. I'm using this mean and this standard deviation. So what I'm writing here is that there is a 19.59% chance of observing a sample difference in proportion of at least 0. So this is the true difference. They took some samples and they observed this difference here. The likelihood of observing at least 0 is 19.59. So in part C, it says, should we be surprised to get a difference this big? So no. I mean, it happens 19.59% of the time. So a difference of 0 or higher is not that unusual. Okay. Here's one of these problems like this in the homework where you just are finding, you're going to check the normal check, find the mean, find the standard deviation, use that to find a probability. Okay? All right, when we do the confidence interval, so this looks the same as it's done before. So you got your first step. This is state what parameter you're going to estimate at what level. Your second step. So some things today are the same, some things are different. So if you notice, it still says z interval for proportions. I'm still using the standard normal curve to find my critical values. I'm creating an interval. It's for a proportion, but now I have 2 samples. The random check looks the same, but the problem is you have 2 samples, or 2 groups that were randomly assigned. The normal check looks the same, but again, 2 things to check. The independent check, there's a new part to this. You have 2 samples. You need these samples to be independent of each other. You can't have a scenario in which you got 2 proportions from the same person, or 2 counts or something from the same person. So you need the samples to be independent of each other. And then you need the observations within the sample to be independent. So either you did an experiment, then you're good. If you took a sample without replacement, then you're checking the 10%. Again, check both samples. This is the formula for the calculator. I will show you it. The calculator is much more friendly to use. Just a lot of opportunity here for error if you typed it, if you just try to use the formula. So the calculator is a lot easier to use. You would just do like you did before with their inputs. The collusion looks the same as it's always looked, except now we're talking about a difference. All right, this is back to the Obama problem in the beginning. So we want to find a 90% confidence interval for the true difference in proportion. So notice here it's a difference in proportion. We never do with the addition. That would never make any sense really. This is a 2 sample Z interval for proportions. Said right here, so in the 2010 sample, they randomly selected. In the 2009, they randomly selected. When I do that normal check, I have to check it for both samples. This one right here, so I'll just make, I think what I want to do here is I want to do 2010 minus 2009. So the calculator would put this one as P1 and this one as P2. So I'm going to make my 2010 one. So the 1024 be my first one. I am using the hats here. The other one was 1010 from 2009, and that was 0.53 for the hat there. So all of those were at least 10. All right, I'm going to assume these samples, remember there's a new part here, so I'm going to assume the samples independent of each other. So what I mean here is I'm assuming that the 2009 people who was ever in that 2009 sample were not the same people that were in the 2010 sample. Both of them are samples, so then I'm going to check the 10% condition. So let's see, oops, I don't know why I wrote 25 there, sorry, it's supposed to be 24. Assume 10,240 adults and 1,100 adults from 2009. Okay? All right. Then, if I were using I'll show you both. I'm not gonna even type the formula into the calculator though, but I'll just show you what it would look like. So if I were going to use the formula, I would have P hat 1. So in this case, I'm using 2010. So that would be the 0.5. So I'd have 0.5 minus P hat 2 plus or minus. I'm doing a 90% confidence interval, so it's 1.645 times the square root. So it would be p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. That's what the formula will look like. Again, you're welcome to type it in the calculator. Try to solve it that way. I think it's easier to go here, so I go to Stat, Tests. Now we're looking at the ones that have the number 2 in front of them. Still doing an interval. Remember, I told you the word prop is always written when it's about a proportion. So 2 prop z interval is option B down here. Just like before, remember these x's have to be counts. So if I'm doing this one right here, I get 512, so that's good. But when I do this one down here, I get a decimal, I'm going to get an error message. So I've got to put that as a whole number there. I'm going to switch that to 0.9. Just like before, you're going to tell me what the inputs are. I'm going to label these here. So this is 2010. This is 2009. I'm going to hit calculate. Here's my interval. So, and then down here, I'm going to also talk about which way I did my difference in here. So we are 90% confident the interval negative 0.0661 to 0.00674 captures, I'm going to put this in context, the true change in Obama's approval rating, and I'm going to say 2010 minus 2009. And then one thing to note here, I got some numbers negative, I got some numbers positive, I got 0 in the middle. So even though it looks like it went down, so 53 to 50%, that was just from my sample. If I create the confidence interval, and so I infer back to the population, it's possible that there was actually no difference between the 2 years because 0 is contained in that interval. Okay? All right. You pause the video, try the next one. I'm giving you another 5 seconds to pause the video again. All right, well, if you didn't pause the video, this is your last chance to pause the video before I reveal the answer to you. All right, so one number from a sample is probably not the same as the value in the population, so it's best to report it at range of values. Again, if you get one difference just from your sample or your samples there, that's only one. It's just from a sample. If I repeat this process and take another sample, I'll probably get a different one. So it's best to kind of report a range of values. This one I did 2013 minus 2012. If you flipped it, these numbers would be negative, okay? And they'd be flipped. 2 samples, the interval proportion. There's my random. There's my normal check, all at least 10. Again, check your work. Samples independent from each other. Assume at least 10,110 adults in each year. There's my confidence interval. 90% confidence that captures the true change in the proportion. Is there convincing evidence? Even if you flipped it the other way, 0 still should not be in your interval. So yes, 0 is not in the interval. Okay? That is it.